Alright, starting lesson 4.6a, graphs of other trig functions. Okay, well we worked with sine and cosine, now we're working with tangent. And for tangent, there are 7 key graphing rules. The first is that there's one intercept per cycle. Alright, so here's one cycle. And you notice that with tangent, it's not one continuous graph. Alright, it's separated by these asymptotes. And there's 2 of them per cycle. One to the left and one to the right. Now, a normal period or cycle, the length of it is pi. So for sine and cosine, it was 2 pi. For tangent, it's pi. Now, with sine and cosine, we divided the graphs into 4 parts, all right, for the cycle. But for tangent, you simply divide it into 2 parts. Now, there's a starting point, and that's at the origin. All right, and then from there, once you get your increments, when we divide it into 2 parts, we're going to move one increment to the left and one increment to the right. And that's how we obtain our asymptotes. All right, now between every cycle is an asymptote, and the graph moves right. As it moves right, it moves up, and as it moves left, it moves down. Okay, let's do some examples. Graph tangent of 2x. Okay, here's your b value. That's going to have an impact on the period. All right, now you don't have to worry about amplitude for tangent because it keeps going up forever and it keeps going down forever. Okay, so let's figure out what our new period is going to be. Now, a normal period is what? It's pi for tangent. And in this case, my b value is 2, so I divide by 2. And that's all I need there. And I'm going to divide the graph into 2 parts. Well, what is my period? My period is pi over 2. I just figured it out. And I'm dividing it into 2 parts. So I'll write this as a complex fraction. And you get 1/4 pi, or pi over 4. Okay, so what are the important details regarding tangent? It has a starting point that's at the origin. So here's my starting point. Now I'm going to move one increment to the left. What are my increments or parts? Pi over 4. So where's pi over 4? Based on the fact that I have negative pi right here, pi over 4, or negative pi over 4, is going to be right here. All right, that's where one of my asymptotes is. And then I'm going to move right, pi over 4. That's where my other asymptote is. Alrighty, and from there, I start from the bottom, I work my way up, and right when you get towards the x-axis, it starts to turn in, and then it turns back up. There you go. There's the graph for tangent. And if we wanted to cover the whole graph, we just go to the right one increment. There's my intercept. Asymptote, intercept, asymptote, intercept, asymptote, intercept, back the other way, intercept, asymptote, intercept, asymptote, intercept, asymptote, intercept. And then I have my graphs. Alright, so pretty simple stuff. Alright, and once again, this is like a type of wave. Sort of looks like water ripples, doesn't it? Alright, and this one stops right there. Right. Okay, next example. Example 2, we're going to have a phase shift. Okay, so let's see, what is my period for tangent? It's just pi. Alright, now I have to figure out what my starting point is going to be. Alright, so I set x minus pi over 2 equal to 0, x is equal to pi over 2. Alright, now I don't need to figure out a finishing point because I'm going to move to the right a certain amount and to the left a certain amount, and that's going to give me my asymptotes for my graph. Alright, and I'm going to divide the graph into 2 parts. So I take the period, which is pi I divide by 2. Another important piece of information. Okay, so where does my starting point go now? It's originally at the origin, but it moves to the right now, pi over 2. So there's pi over 2. All right, from there I go to the left using my increments, pi over 2. So there's one asymptote. And I move to the right, pi over 2. There's another asymptote. And I start from the bottom, work my way up, and there we have it. If we want to cover the whole grid, just repeat the pattern. Pretty simple stuff after you get the first one. All right, that's all there is to it. All right, now we're working with cotangent. All right, there are, once again, 7 key graphing rules. Now, cotangent is very similar to tangent, but instead of there being a starting point, there is a starting asymptote. Okay, and it's at x equals 0. There's my starting asymptote. All right, and instead of moving to the left and to the right like we did for tangent, we only move to the right. So once you have your asymptote, then you move to the right one increment, and that gives you your intercept, and then you move to the right again, and that's your next asymptote. All right, now between every cycle is an asymptote, and the graph moves left and up, or right and down. Left and up, or right and down. So as you move from left to right, you're starting from the top, and you're working your way down. All right, let's do a couple examples. All right, normal period is pi, but here I have b. So my b is 1/4, so I divide by 1/4, complex fraction, no big deal, simple stuff. So 4 pi is my period. Now I take the period and I divide it into 2 parts. So I take 4 pi and I divide by 2, which is 2 pi. Alrighty. Now, here's my starting asymptote, x equals 0. And then I move to the right using one increment, so 2 pi. And then I move to the right again with another increment, 2 pi. I get another asymptote. Okay, and with tangent, you start from the bottom and you work your way up. But with cotangent, you start from the top and go down. All right, and we'll cover the whole grid. Go to the left, pi over 2, or sorry, 2 pi. And then go left, 2 pi again. I have asymptote. Start from the top, go down. All right, next example, and the last one. All right, working with cotangent, and here I have a negative, so I'm going to reflect my graph, and you don't have to worry about the 2, because there's no amplitude when you're working with cotangent. It just sort of stretches the graph out, but since you're coming up with an approximate graph, it doesn't really matter. And then let's figure out the period. Normal period is pi. My b value is 2 though, so divide by 2. Then I have a starting asymptote that's shifting. So I set 2x plus pi over 4 equal to 0. Subtract pi over 4. Then divide by 2. And x is equal to negative pi over 8. All right, that's my new starting asymptote. And then I have 2 parts. I'm dividing the graph up into. So I take my period, pi over 2, and I divide it by 2. All right, so it's a complex fraction, simple stuff, right? Just like before, of pi over 4. All right, so at negative pi over 8, I have my starting asymptote. I'll say every one of these units here, increments on the grid, is pi over 8. So that's negative pi over 8. That's my starting asymptote. And then from there I move to the right, pi over 4. Now pi over 4 is equivalent to 2 pi over 8. So I move 2 eighths, takes me right there. I move over 2 eighths again, and it takes me right here. All right, and last step is to graph cotangent. Now normally I start from the top and I work my way down, but since there's a negative, I'm reflecting the graph, and now it looks exactly like tangent. All right, so whenever there's a negative in front, it looks like the opposite for the tangent or cotangent functions. All right, now if I want to cover the whole grid, just do something like this, and like that. And I have my graphs. Okay. Well, that's all there is to it. This one you could say is down here a little bit. All right, that's all there is to it. If you have any questions, please make sure to ask. Begin the assignment at the bottom of the webpage.